Hello, my name is Sotirios Arkontoulis. I'm an associate professor in the Department of Agronomy, Iowa State University, and today I'm gonna review the 2021 cropping year. Every cropping season has its own challenges, and in 2021, the number one challenge we had to face was the limited precipitation. The precipitation was below normal. However, at the end of the season, at harvest time, the yields were better than we anticipated during the growing season. And as I mentioned, if I look back in time, in 2020, we had another major challenge, which was the ratio. In 2019, we had delayed plantings. In 2018, we had extreme rainfalls in the month of June. But in all cases, as far as I remember, the yields at the end of the season were better than we were expecting while the crops were growing. And this is a good indication that the Iowa crop production systems are becoming quite resilient to any type of weather events. I will cover two topics in my presentation. The first one, and the most important, is the review, the findings from my analysis on why the yields were high in 2021. We will review data from USDA at state level. We will look back in time. We're going to compare Iowa with other states. And then we will move to weather indicators, including precipitation, radiation, soil indicators. We are going to see some data with soil moisture, and we will end the review with some modeling analysis. The second topic that I'm going to cover, and briefly I'm going to mention, is about the optimum nitrogen and optimum planting densities for corn in 2021. And we're going to review some experiments that we had all over Iowa. Let's start with the USDA NASS data. On the top left panel, you see the corn yield with the black thick line to represent Iowa and the different thinner colored lines to represent different states. In year 2021, Iowa, according to November forecast, is expected to have 201 bushels per acre corn, which places Iowa number 2 in terms of bushels per acre after Illinois. On the right-hand side, you can see the production, the total bushels per state, and over there, Iowa is still number 1 in terms of total productivity. In terms of soybean yields, Iowa was placed number third with 60 bushels per acre soybean after Illinois and Nebraska. And in terms of total production, Iowa was number 2 after Illinois with 0.6 billion bushels. One important thing to consider as we move our analysis is the planting date. This year, we were able to plant both corn and soybean by the first week of May. And in this graph, you can see planting dates, 50% of USDA NASS progress from 2010 all the way to 2021. And this year, we had probably one of the earliest planting dates. This is very important. We should not ignore this as we move and we try to interpret high yields in 2021. A very good planting is probably half of the success because it can set a very high yield potential. And in addition to planting dates, I want to bring here that a week after planting, we had a rainfall. I remember that was May 9, which is very important for uniform emergence, seed emergence. Moving to the precipitation, what you see in this panel is a series of monthly precipitation trends for the state of Iowa. Each panel represents a crop reporting district. The orange line is the 35-year average, including the standard deviation, and the blue line is the 2021 precipitation. In most of the crop reporting districts, precipitation was below normal. The only exception was the southeast Iowa, where precipitation was at normal or a little bit above. There was variability from one crop reporting district to another, but what I want to draw your attention is that the blue line, which represents the 2021 precipitation, yes, it was below normal, but it was within the standard deviation. It did not went below the standard deviation, and this is very important, and I will explain this in the following slides. Now, regarding this data, I retrieved this data from the extension website that we called Fax Weather Tool, and it's easy to use tool. You can go select a crop reporting district and download all the data and make your own graphs. Back on the precipitation patterns, I selected 4 different weather years. The top left is for the year 2021, where the yields are expected to be 201. The top right is the year 2017. The bottom left is the year 2012, and the bottom right is the year 2018. 2021 and 2017 were both moderate dry years. You see the blue line is below the orange line, which is the 35-year average, but within the standard deviation. The year 21 was within the long-term average variability. And both years scored high yields, 2001 and 2002. For reference, the record yield in Iowa is 203 bushels per acre, and this was obtained in year 2016. To contradict these patterns, I have at the bottom 2 unfavorable precipitation patterns. On the left is the year 2012, and there you can see that the blue line was below the standard deviation of the 35-year average. Also in 2012 we had high temperatures, but this is a precipitation pattern that is not favorable for Iowa. And the other one, the other extreme, is the year 2018, where we had way above normal precipitation in June. And in that year we got quite a yield penalty. Trying to summarize all the different weather years and the precipitations, I plotted the normalized yield for central Iowa. By normalized, I mean the historical yield over the last 35 years. I just removed the trend, the yield increase, to make it a normalized yield, and I plotted that as a function of summer precipitation. At the bottom, you see a horizontal bar over there, which represents the mean summer precipitation plus minus the standard deviation. The range is quite large, from 8.3 to 19 inches, and you can see the points for corn and soybean, the yields, are at highest values when precipitation is within the mean plus minus the standard deviation. When precipitation is below or above this range, this is when we see high yield losses. For reference, the year 2021, in year 2021, we got 9.17 inches of rain, and this was only 0.8 inches above the yield reduction limit. So we were very, very close. It was a matter of 1 inch. Now, trying to scale up the data from one crop reporting district to the entire United States, I'm presenting you here some data from the literature, paper published in 2019, where researchers from Illinois, they regressed the yield change, percent reduction, as a function of precipitation anomaly. On the bottom left graph, you can see data for Iowa, and there the red color represents yield loss when we have too little water, the extreme dry situation. When the precipitation is near normal, usually we have yields above normal, the 35, 40 years data that they use that one. And as we move to the extreme wet case scenario, we get a severe yield penalty in Iowa. For reference, Illinois, which is the top right graph, they have other type of limitations. They are more sensitive to dry than to excess water than Iowa. Two states that are one next to each other, but they face different limitations regarding to the water. And this is nicely illustrated in the two middle maps we have there. In the top one shows areas which are sensitive to extreme drought. And you will be surprised that there is nothing there for Iowa besides 5, 6 counties. There are not many areas sensitive to extreme drought in Iowa. However, there are many, many areas, counties, I think this is more than 65, 70%, that are sensitive to extreme rain. So as we are thinking about precipitation during summer and yield levels, we should worry more when we have too much water, and we should worry less when we have too little water in Iowa. And as long as the precipitation during summertime is within the standard, the median mean plus standard deviation over the last years, the yields are gonna be good yields. We are not gonna get any major yield penalty due to drought. The amount of precipitation is one important indicator, but the timing of precipitation is equally important. We could not have asked for a better distribution of precipitation in 2021. And you see here a map from Iowa, actually daily map with precipitation from Iowa. I got this data from Iowa Environmental Mesonet, and I was impressed to see that we get so many precipitation events. It was over 30, but in different parts of the state. It was not concentrated in one portion of the state. On the left, I have highlighted some important rain events, and the first one is May 9, something that I mentioned early in my presentation, where it was really, really helpful for uniform crop emergence. The other one is end of June and early July. Probably these were the most important precipitation events, exactly at the most critical phase for crop growth. And also we got important rain events during grain filling period, especially at the middle towards the end of grain filling period. And of course, we got some rain events in August, which are very welcome because enhance the soil moisture for the next cropping year. Moving from precipitation to radiation and temperature, according to data at Crop Reporting District again, temperatures were near normal. And I have there two plots at the bottom where you can see the minimum and the maximum temperature were very close to normal. However, radiation was 7% above normal during summertime. And as a rule of thumb, 7% more sunlight approximately is equal to 7% more yield because of the linear relation between biomass production and radiation interception. The higher radiation in 2021 was mostly because of the lack of clouds and rain events. Now, some people ask me about the clouds that created by the wildfires that we had this summer in California and moved over parts of Iowa. And in this graph, you can see that northeast portion of Iowa was highly covered by the smoke, creating conditions that may reduce radiation. And here is another beautiful picture, which I borrowed from Mark Chesley from a nice report, Crop Insights. And overall, there were quite some discussions and questions about the wildfire smoke. And it is complex because it affects processes in different ways. Like it can reduce total radiation, which according to the data that I presented before, it was not the case for Iowa in 2021. Probably the lack of precipitation or cloudiness from didn't allow us to see a major reduction in total radiation. But another important aspect of the smoke is the increased diffuse fraction of the light. This is really important, and I will show you some more data on that, and I will discuss this more. And another impact of the smoke is the increased ozone levels, and to some extent it may change the temperature, which for 2021 was not the case according to the data that I presented you before. Diffuse radiation. When we have shade conditions created by any kind of cloud, we have increased portion of diffuse radiation. The diffuse portion of radiation can penetrate deeper within the crop canopies. The direct light, the incident radiation when we have at clear days is mostly intercepted by the top canopy. The diffuse is the one that can go deeper into the canopy and bring light in the bottom leaves, which are operating at low light levels. What does this mean? It means that total canopy photosynthesis can increase. Now, the numbers by how much depends on the states, on many conditions, but in general, according to the data we have in the literature, diffuse radiation is beneficial for canopy photosynthesis. Here are some data from the literature from Canada in 1993, where researchers measured photosynthesis. On the left panel, you see net photosynthesis versus radiation intercepted. The open symbols refer to cloudy conditions, and the filled symbols to clear sky conditions. And as you can see in this graph, when we have cloudy conditions, photosynthesis is getting higher. Of course, the amount is less than clear days, but the efficiency is much higher. And talking about the efficiency is the second graph on the right, where you see the radiation use efficiency at the leaf level, and in the x-axis is the proportion of diffuse to incident radiation. So as the proportion, as we get more diffuse light, the efficiency, the conversion efficiency of sunlight to dry matter is increasing by a lot. So this is very good for crop production. Getting the yield equation, yield equals radiation interception times the efficiency times the harvest index. Overall, the smoke can decrease the total radiation, but in our case in 2021, it was not enough to decrease radiation. It can have some negative effects through the ozone, but overall, the smoke can alter the portion of diffuse light that we have. And I believe that was a case for crop production in 2021, where we had some benefits because of the smoke. Now, talking about smoky conditions and future and wildfire in general, I found recently a paper that was published in December, and they ran future models to see What's gonna be in the next 40 years with regards to wildfire and smoky conditions? And the conclusion from their study, the results showed that in the future, there are 50% chance to have more wildfires than we have from the period 2000 to 2010. So this is another aspect we have to consider in crop production as we try to manage crops. In the past, that was a factor we never thought about it, or it was not important, but perhaps in the future may play more and more significant role. The next weather indicator I want to review is the relative humidity. I have heard discussions about humidity was high in 2021 and this caused less evapotranspiration. However, data from central Iowa do not support a higher relative humidity in 2021. This is one location, and if I'm gonna show you the entire state, the entire United States, I got data from climate aging, and this is the minimum relative humidity. The brown color indicates that the humidity, the minimum relative humidity, was below normal, and the green color indicates that humidity was above normal. And majority of Iowa was in the brownish color, which means we have a lower minimum relative humidity, which is an indicator of dry conditions. Another weather indicator, a bit better than relative humidity because it factors both humidity and temperature, is the vapor pressure deficit. And the higher the vapor pressure deficit, the higher the chances of crops realizing stress. And according to just weather data, Iowa was in the red color, so vapor pressure deficit was higher than normal. Moving from weather to the soil conditions, some data from central Iowa again, which data are for 24 and 50 inches depth. The red line is for 50 inches and the blue line is for the 24 inches. And these data are over the last 3 years. Within the black cycle there, I indicate the last 2 years. What happened, 2020 and 2021. We started the growing season with below normal soil moisture. And this was what we carry over from the previous year. So we started low. And we were below normal. We knew that. And according to the calculations that I did, it was on average 16% less moisture than what we used to have in the previous years. Deeper in the subsoil, I ran a simulation model to see what was going there and to estimate the contribution, which I'm going to show you that later. Again, the depth to the water table was 3 feet below what we have as normal for central Iowa, and this was carried over from the previous year. The soil moisture across different crop reporting districts, again, we were below normal, but very important, we were within the variability that we realized in the previous years. So we didn't have any type of record low soil moisture at any of the crop reporting districts. And of interest is that 2021 soil moisture patterns followed quite closely the 2020 soil moisture patterns. We reviewed weather indicators, which gave the message from that was we had stress, we had water stress. We also reviewed soil indicators, and in the next couple of slides I want to talk about some crop indicators, and I will talk about the precipitation water use efficiency. Basically, it is the ratio how many bushels of corn or soybean we make per inch of rain. It's another way of evaluating crop production, but instead of bushels per acre, the discussion is going to be bushels per inch of precipitation. And I believe this will become more relevant as we move into future years with the expected precipitation patterns that are going to change to more spring and less summer precipitation. So we are going to use more this indicator in the future. I used crop reporting district data from USDA NAS for Central Iowa and summer precipitation again for Central Iowa Crop Reporting District from the Iowa State University Extension website. And I plot the time series, and it was interesting to see there that the pattern is increasing. The water use efficiency, precipitation water use efficiency for corn in Iowa was about 10 bushels per inch of rain back in 80s, but today it can be all the way to 20 bushels per inch of rain. For soybean, the trend is the same, increasing over time, and this is mostly because of improved genetics. However, the water use efficiency for soybean is substantially less than corn, and this is because of the different photosynthetic pathways. Corn is a C4 plant species, soybean is a C3 plant species. But it's important, and we need to think more about the water use efficiency, that today's hybrids require less water to produce the same amount of yields. So we should update our knowledge about water, crop water stress, and we should factor in the improvement that we see in the hybrids. The water use efficiency decreases as we get more rain, and the same data plotted differently. Just I want to show you here that in 2021 cropping year, we got about 9 to 10 inches of rain, and the water use efficiency for corn was about 20, and for soybean was about 6 to 7. There are many definitions of water use efficiency. The one that I present you here is the simplest that we can make. The most agronomic relevant definition is when we divide the yield with the evapotranspiration, or even better, the transpiration. I found some data in the literature, maize era studies. The first one was from Argentina, an environment similar to the United States Corn Belt. The scientists, they ran experiments for over 8 side years. They used 4 Bayer hybrids and a range of management factors, including planting density, irrigation. And they found that the yield was increasing about 0.5% per year. What they found in addition to that, it was the water use efficiency was increasing at exactly the same rate as the yield, 0.5% per year. And if we make the calculations, this is the water use efficiency is 10 bushels per inch of evapotranspiration per acre. Additional data from the literature from California environment, way different environment than United States Corn Belt, higher temperatures, even higher than 100 Fahrenheit during summertime. There was another maize study there, 2 side years with 18 Pioneer hybrids. You can see the yields on the left axis for 2 different years. The range was from 37 to 150. It was increasing over time. However, on the right panel, you see the water use, how much water hybrids use to produce this yield. And regardless the yield increase from 60s to 2010, the water use was about the same. And if we make calculations, the water use efficiency in this environment was about 9 to 10. And this is a clear evidence that the water use efficiency in newer hybrids is much higher than the older hybrids. So in other words, newer hybrids can buffer way more water stress than the older hybrids, which is good news for crop production. The last part of my analysis for 2021 cropping year, it was to run a model and to explore some scenarios. The first scenario that I explored for 8 different locations, and after running the model for 8 locations, I summarized the data. It was a scenario with irrigation. So in this case, the yield was 250 bushels and the standard deviation was 25 bushels. Compared to the normal scenario, which is a rain-fed crop production, irrigation added 37 bushels per acre. In other words, increased yield by 17%. The other scenario that I explored through modeling was to remove the shallow water tables that Iowa soils have. In that case, by difference, I estimated that 63 bushels per acre in 2021 cropping year was coming as a credit by the high soil moisture, subsoil moisture in Iowa soils from the water table. And the fertilizer, it was 66 bushels per acre, 45% increase. So scenario analysis is always helpful to see what is possible and which factors contribute to yields. It's something that we can learn and we can use this information for the future. To summarize the review of 2021 year, and I'm ranking in this slide the most important factors. To me, the number one factor for the high yields was the timing of rain. The amount of rain was within the standard deviation of the last 35 years. We could use a little bit more rain, but in general, when we are in the dry, moderate dry side, this is beneficial for Iowa. So the timing of rain this year was extremely important. Number two factors is the water use efficiency. Newer hybrids have higher water use efficiency. They can produce the same amount of yield with less water. So it's important to consider that. And also in the future years, it's not only for 2021. The number three factor is the water table. Yes, the depth of the water table was below normal, but what is important is that the water table through capillary fringe pushing the water upwards, and this making the subsoil wetter, increasing the moisture. And I believe the deep rooting systems that crops developed in 2021 used all this water. The number four factor is the radiation. We had 7% on average higher radiation, and at the same time, for a couple of days during the growing season, we had all this smoky atmosphere which increased the portion of the diffuse radiation. So we have two components to consider with regards to radiation: higher amount and also diffusion, higher portion of diffusion. This is not something we get every year. That's really exceptional. And the fifth, but really important, and we should not forget that one, is the time of planting. It was an excellent planting time, the earliest, among the earliest, and it accompanied by a precipitation event a week after planting that resulted in a uniform crop emergence. To me, this is really important because when you plant the crops early, you set a very high yield potential. So this year we set a very high yield potential, and we were able to carry over this yield potential up to the harvest time. Overall, the 2021 cropping year, it was a win-win-win win year. I don't think we had a year like this in the previous years. Why is that? Because we had high productivity. At the same time, corn prices were really high. The environmental performance was high. According to simulations and field experiments, nitrogen loss from the soil was minimum to zero. And also, we have a high carryover of nitrogen. Since we did not lose the nitrogen is still in the profile and something we can use in 2022 year. It's really exceptional and very good year. And to give you a few examples, in 2012 year, profitability and environmental performance were also high. But in this year, productivity was low. In some other years like 2016, productivity was higher than 2021, but the price of corn was lower. It was close to $3 or something. But this year we were able to have both high productivity, profitability, and also the environmental component. Talking about the environmental component, I'm gonna move to the second and brief portion of my presentation, which is about the optimum nitrogen rates and planting densities. In 2021, in my lab, in collaboration with other faculty in the Department of Agronomy, we had a couple of trials. The first category is the long-term nitrogen experiments with 2 rotations, 7 locations for a total of 14 yield response to nitrogen trials. And the second experiment was a complicated one with 2 rotations, 5 hybrids, each from a different seed company, 5 densities for a total of 50 yield response to nitrogen trials. On the right, you see a summary optimum nitrogen rate, economic optimum nitrogen rate across all the experiments. The median for the corn after corn, the blue bar, was about 175, 180 pounds per acre. And for corn following soybean, the optimum nitrogen rate was 140. These values are a bit below normal, a bit below what the values are in the MRTN calculator. Looking at the optimum nitrogen rate values is good, provides information, but I like to have a systems overview, and I will present you here the yield at the optimum nitrogen rate. It was about 180 pounds per acre, bushels per acre for corn after corn, and close to 210, 220 for corn following corn. The yield at zero nitrogen, however, it was near 70 bushels per acre for corn after corn. This is close to what we used to get for corn after corn. However, according to our data, the yield at zero nitrogen in corn following soybean was exceptionally high in 2021. The median yield was close to 150 bushels per acre. This is high compared to the previous years. The difference between optimum yield and zero yield, which makes the responsiveness to nitrogen, was about 120 and 60 bushels per acre. Nitrogen use efficiency, close to 0.7 for corn following corn and 0.5 for corn following soybean. And the other way of looking the efficiency is the pound of nitrogen for each bushel of corn. The values there was 1.1 for corn following corn and 0.7 for corn following soybean. This is average values across 64 yield response to nitrogen trials we had in 2021. The complex experiment, the one we call it 5 by 5 by 5, here is a layout of the experiment, a drone image that we took sometime end of August. It was Central Iowa, and I want to show you one plot from the entire experiment. And this is the plot which, in my opinion, was the worst corn in Iowa in 2021. And I will tell you why. We used 60,000 seeds per acre, really high, normal is 35. We used zero nitrogen per acre. We usually put 150 to 200. And the previous crop was corn. And you can see there Alejo Ruiz, one of my PhD students, studying in these plots. And some of the plants, besides the color which is yellow, they did not make ears. So it was very stressful conditions. On the other side, on the right side, I show you a picture of the good corn with normal density, enough nitrogen. Data, yield response to nitrogen on the left and yield response to density on the right, across everything. Just the first impression of the data. And in our analysis, before I show you the results, I want to state the hypothesis. We were expecting to see that the optimum nitrogen rate will increase as the density is increasing. However, this is not what we found in 2021. For corn following soybean, for corn following corn, which is the blue bars, you see that as we were increasing the density from 20 to 30 to 40, 50, and 60, the optimum nitrogen rate was decreasing in the first hybrid, in the second hybrid, third, fourth, and fifth. And the pattern was about the same and a little bit more complex for corn following soybean. This is against what we were expecting to see. And if I try to summarize all the different hybrids, take the average, this is a summary plot for corn following corn and corn following soybean. It was a decreasing pattern with an exception of one point, the corn following soybean at really high densities. But if we exclude this point, it was a linear decrease with increasing plant density. However, the yield response to plant density followed a more expected pattern. It increased, reached a plateau, and then started declining. The yield without nitrogen for corn following soybean followed to some extent expected pattern, a polynomial pattern. However, corn after corn, the yield was decreasing almost linearly as we were increasing the plant density. And the nitrogen use efficiency was increasing in all cases. If I remove one point there, it was increasing with increasing the plant density. Now, we believe that the results on optimum nitrogen rate as a function of planting density is different from the previous years and in contrast to our hypothesis, and we believe the reason for that is the precipitation. So the yield response to nitrogen for different plant densities is conditional to how much water we're going to have every year. 2019 was a relative wet year, especially early in the season. 2020 was dry and wet to some extent year, but 2021 we didn't have as much rain as we had the previous years. So this is research that is still ongoing. We will continue researching the interaction between density and hybrids on the optimum nitrogen rate, and we will update you in the next years with the new results. The take-home messages from this nitrogen analysis is that the optimum nitrogen rates in 2021 were a bit below normal, and the plant density increased the nitrogen use efficiency, but the effect of density on optimum nitrogen rate is conditional to the water availability. And the overall conclusion from the 2021 cropping year review is that Yields were better than we anticipated. Everyone, including myself, I was expecting lower yields, given how dry it was during the summer. But things were different, and I strongly believe that crop production in Iowa is becoming more and more resilient to weather extremes. And we should remember the 2021 year because it was a year with 4 winds. We had high production, very good market prices for corn and beans, and with limited nitrogen loss from the soils. In addition, we have nitrogen that we carry over into the 2022 cropping year. And with that, I want to thank you for attending this presentation, and I want to thank my group for running the experiments, collecting the data, my collaborators, and at the bottom right of this slide I have my email, and I will be happy to take any questions and provide any additional information. Thank you for watching this presentation.